Okay, so these last two examples kind of stem from these last couple formulas they give you in the book. So if you're looking at page 373, this formula right here is the formula for the length of a circular arc, meaning this right here. And that is S equals R times theta. So what that means is this outside arc equals radius times this inner degree theta. And then the last one is the formula for the area of a circular sector, which is the area of this inside part, if I were to color all of that in right there. So that area is 1/2 times the radius squared times that inner angle theta. Okay, so this first one, they give me this problem where they say a central angle theta is subtended by an arc 10 centimeters long on a circle of radius 4 centimeters. So what they're telling me is from here to here, that's that subtended by an arc 10 centimeters, they're just telling me that that is 10 centimeters. And then they're telling me that the radius is 4. So I went ahead and wrote those in. In your book, if you look at this example, they write those in, but they also write the answers in. So it doesn't really help. I feel like seeing a blank one is helpful. They want me to approximate the measure of theta in degrees. So this right here, they want me to find theta. Okay, so I'm going to use that first formula then because they told me that S equals R times theta. So that S that they gave me, which was 10, equals my radius, which was 4 times theta. So if I divide by 4, theta equals 2.5, or I could have said 2.5, right? The problem is that is in radians. This 2.5 is in radians because all of these measures are just plain measures. They're not giving me anything having to do with a degree. So when I get that answer, I'm getting it in radians. They want it in degrees. So I'm still going to have to convert that 2.5. So I'm just going to write it like this, 2.5 times, remember how we do that, go back to your, in your book on page 371 is where they give you that table that says if I'm going from radians to degrees, I multiply by 180 over pi. So I'm going to multiply by 180 over pi, and that's going to give me my degrees. So that ends up about, I went ahead and did this on a calculator, so 143.24 degrees. I'm just going to stop there. Okay, part B is they want me to find the area of the circular sector determined by theta. So again, this area of the circular sector is the area of that chunk right there of the circle. So that formula that they gave me is 1/2 times my radius squared times theta. So in this case, that's 1/2 times 4 squared times theta. I'm going to use that radian degree measure because I want my answer to be in centimeters. Because we're talking about area, it would be centimeters squared. So I don't want a degree getting in my way. So I'm going to stick with this 2.5. So that's going to be 1/2 times 16 times 2.5. So that's 8 times 2.5, which ends up 20. And again, that's in centimeters, but it's centimeters squared. So I'm going back to my units here. This is centimeters, but if I'm talking about an area, that's centimeters squared. So 20 centimeters squared would be my area. All right, example 6. Suppose the wheel is rotating. So this wheel over here, this was actually in your book, it's a tire wheel. And they're telling me it's rotating at a rate of 800 RPM, which is revolutions per minute. They want me to find the angular speed of the wheel. So this is a whole different scenario. So to find the angular speed, I'm going to write it out here. Angular, not angular, angular speed. I'm going to take that revolutions per minute that they gave me, which was 800, and I'm going to multiply that by 2 pi. And why would I do that? That's because that's one rotation around that circle. I really could care less about what this diameter is. All I care about is how long does it take me to go around one time. That's 2 pi. Okay, so remember the circumference, we talked about that earlier, is 2 pi radians. So let me write my revolutions, my units in here. So this is 800 revolutions per 1 minute. And this is 2 pi radians per 1 revolution. So why is that important to me? So if you go back, revolutions are going to cancel, and I'm going to end up with radians per minute, which is my speed that I'm talking about. Okay, so that's going to give me 800 times 2 would be 1600. And then I've got pi still, so it's 1600 pi, and that's in radians per minute. That is my speed. Okay. The second part of this one may take a little bit longer. So this one says, find the linear speed in inches per minute and miles per hour. So I have to find 2 answers here of a point P, which was in that picture I just showed you, so P right here, on the circumference of the wheel. So linear speed, I will give you this formula here. Linear speed is the radius times your angular speed. So in this case, that's not going to be too bad. That's pretty easy. My radius, they gave me that my diameter was 24. So my radius is 12, and this was in inches. So I'm going to write that out so that I don't forget. And then times my angular speed, which I already had, which was 1600 pi, and that was in radians per minute. So that ends up, if I multiply those, that gives me 19,200 pi. And this was 12 inches per radius, because that was my radius. And this was in radians per minute. So this ends up inches per minute, because those radians just kind of cancel out. So there's one answer already. They wanted it in inches per minute. The problem is they also wanted it in miles per hour, so I'm going to have to do some conversions. So I hope you guys remember back to your stoichiometry days. I think this is going to strike a chord a little bit. So that 19,200 pi, that's in inches per minute, right? Now I need to get my minutes to hours and my inches to miles. So I don't care what order you do those in. I'm going to go ahead and go to my hours first because it just seems quick and easy. So I'm going to say I need to figure out what it is in hours. There's 60 minutes per hour, right? So this is going to cancel out my minutes and make it inches per hour, okay? But then I'm also going to have to change my inches into miles. So I have kind of 2 steps I need to go through for that. One would be, let's go to feet first. So inches to feet, and I want my inches, so let me kind of walk you through how I do this. I want my inches to cancel out, right? And I want to go to feet first. So what is that conversion with feet and inches? Well, there's 1 foot is 12 inches, right? So that will get me to feet per hour. Then I want to go from feet to miles. So I'm going to want to cancel out my feet and go to miles. Well, 1 mile is 5,280 feet. So again, that will cancel out my feet. Now the only units I have left on top are miles. On bottom are hours. So that's miles per hour. So if I do all of that, I end up with, if I keep pi in there, like I did on this one, I end up with 18.18, and that keeps repeating, 181818. And that was, times pi, and that was in miles per hour. Or I could go one step further and say, really, that's the same thing. If I multiply that by pi, that gives me 57.1, miles per hour. And the reason why I did that was because that's how the book put their answer. They took pi out of there and went ahead and multiplied it in. You could leave this as your answer, and that would be the same thing, just like I did here. I could also multiply this by pi. I'm guessing they didn't multiply that one by pi because the number was just so large. So anyway, okay, so those are my two answers. They wanted it in inches per minute and miles per hour.